Imagine asking an AI assistant to summarize a web page. The visible article looks normal. Hidden inside the page is a sentence telling the model to ignore its instructions, read private notes, and email them away. If the assistant only summarizes text, the damage is limited. If it can read files and send email, the same sentence becomes a security problem. The issue is not only what the model reads, it is what the model is allowed to do next. Direct prompt injection is the obvious version. The user says, "Ignore previous instructions." Indirect prompt injection is more subtle. The malicious instruction appears in a web page, email, PDF, ticket, calendar invite, RAG document, or tool output. The user may never see it, but the model reads it while trying to complete the task, and that text competes with the trusted instructions. A better system prompt can reduce some failures, but it is not a sandbox, firewall, permission system, or access control layer. Language models process instructions and data in the same medium, text. Attackers can disguise commands as content, examples, markdown, comments, or quoted material. If the only defense is another sentence saying "do not obey attacks," then the security boundary is still the model's interpretation of text. Most LLM apps build one context window from many sources: developer instructions, user requests, retrieved documents, emails, web pages, memory, tool outputs, and available tool descriptions. Some of that text is trusted policy. Some is hostile or user-controlled data. Once it is blended together, the model has to infer which text has authority. That is the architectural failure prompt injection exploits. A plain chatbot can produce unsafe or incorrect text. A tool-using agent can send messages, read databases, update records, run code, create tickets, browse private pages, or spend money. Prompt injection matters more as tool authority increases. The dangerous question is not, can someone write a malicious instruction? They can. The dangerous question is whether that instruction can influence an action with real consequences. The first defense is least privilege. Do not give an agent a universal admin tool and hope the prompt keeps it polite. Give it narrow, task-specific functions. Separate read tools from write tools. Scope credentials by user and session. Disable dangerous tools unless they are needed. Prefer get invoice status, draft email, or request approval over run arbitrary command or update anything. If the model needs to inspect untrusted files, browse unknown websites, or run generated code, isolate the environment, use disposable containers or VMs, mount files, read only. Keep secrets out of the sandbox. Block network access when it is unnecessary. Use separate browser sessions and workspaces. The goal is not to make hostile content friendly. The goal is to make it powerless. For high-impact actions, separate decision-making from execution. The model can propose sending an email, issuing a refund, changing a database row, or opening a cloud resource. The application should check policy, permissions, data classification, rate limits, and human approval before execution. If a tool call is risky, enforce the rule outside the model. RAG adds useful knowledge, but it also gives attackers another way to speak to the model. A poison document can tell the assistant to ignore instructions, leak data, or call tools. Retrieved text should be labeled as untrusted evidence. It should not gain authority over system policy. Safer RAG systems track source trust, filter content, require citations, and validate actions against the original user request. The checklist is straightforward. What untrusted content can the model read? What private data can it access? What tools can it call? Are write actions separated from read actions? Are dangerous actions confirmed by a human? Are tool calls validated outside the model? Are secrets isolated from generated code? Prompt injection is not solved by a perfect prompt. It is managed by designing systems where untrusted text does not automatically become trusted authority.